given that gravity is described by the force F sub y is equal to minus mg, what is the potential energy function that describes gravity? And so what we're saying there, that's basically the weight force. We're saying it as an F sub y because really it just has a downward component equal to the weight. That's what the minus sign there means, right? So we're using kind of vector component notation. But the statement we had for the potential energy function is the potential energy function is equal to the amount of work that has to be done against a conservative force. So if this gravity represents a conservative force, and if I have some object, right, that has this mass m that we're talking about here, okay, and let's say I want to lift this object up, and I'm just going to say, let's establish a coordinate system. Let's say we have like a y-axis here, and I'm saying it starts at y is equal to 0, right? And I'm going to lift it up until it gets to the value y, right? And if I say, well, what's going to be the work that I have to do, right? Because like in that sense, we know that the force of gravity is pointing like this. That's kind of what this force given to us is saying. But the work that I have to do is corresponding to the force that I have to apply. That's this force F, right? And you know, we can just use, I think in this case, since displacement is up, force is up, we can just use the simple F times D rule for finding work. The amount of force I'm going to have to apply is mg, but maybe D instead will correspond to the y value I wind up with. So in that sense, I get mgy. So one way of interpreting that is to say that the gravitational potential energy function as a function of position y is equal to mgy. You might also notice that this is very similar looking to the gravitational potential energy formula that we've used in the past, mgh, but instead of h, I'm using y, which makes it look more like a function. So when somebody says potential energy function, that makes me inclined to use a variable like that. But really, I'm not really doing anything all that different here. But there it is, u of y. I subscripted it here to make it clear that it was gravitational in nature, but there it is equal to mgy, and it says this really is the amount of work done to lift an object of mass m from the origin to a position y above the origin.